Okay, as you know, I'm completely against the current thinking of the atomic model and the speed of light and all of this business. And a lot of this is related to Lorentz transformations. And they use all these things as criteria to prove what they're saying. So look what I know that we can speed up light. We know we can slow down light. Look what they say. I'm not going to go through all the squiggly lines they talk about. It's all nonsense once you get to the point of everything is based on nonsense. And here's the nonsense part everything's based on. Physical implication. A critical requirement of the Lorentz transformations is the invariance of the speed of light. That's variance. that is being sped up. So the whole premise of the Lorentz thing is just, it's not based on reality. There is an extreme difference in the way light can speed up and slow down. And it is related to the pull or push of the particular particles that is in contact with and is being emitted from. How excited are they? How relaxed are they? How much can they absorb? How much are they emitting? All of that is related to the interplay of the particles that's coming into it. Secondly, we can see there's no question whatsoever that is accelerating. This wave is going faster, and you can see the particles in that wave. Everything is being based on these false premises. And Einstein, and then everybody took off after Einstein, saying, "Oh, he must be right because he had this big speed of light number." I mean, it was just as soon as they saw that big number, it was all over. Case closed. The guy got to be right. Too big of a number to deal with. No, he was not right. The speed of light is based on the receiving part, not the speed of light where it's coming from. It's going to have a certain power to those different particles, yes. And we see that, call it speed. But it's not necessarily speed, it's impact. And, well, let's get it to. Okay, I just want to make the point that all of these premises that have been made were not correct. The speed of light is variable. It can speed up going through a venturi. It can slow down going through dense media. It is a particle. We can see those particles, and then they start to display very, very clearly as they concuss one another, which is what they said. Plato long ago said they were luminous corpuscles. And when they smashed into each other, they glowed, and that is a fact. That is what's going on. And these particles own a very large region of a tiny, tiny, tiny particle. And let's see the regions that they do own. All right, that's the region. And the particle is right there. But as it slams into all of these other particles that glow when they get concussed, because it owns such a big region, they all start to glow. Everybody's being concussed, perturbated, thrown into a little bit of chaos. They were sitting around there, just laying around there having a good time, and then all of a sudden, poof, this thing comes through like a hurricane. What's going to happen? They are going to get excited. That's what you see. Now those are particles that have come through the accelerator, coming out of that brilliant white spot down there. Those little tiny white trails are what they call the particle bosons, that a boson charged particle carrier, which is spinning like hell. You can't see it because it's going so fast now that it can't even create a field until it smashes in and slows down in the space that it is invading. And the particles that are being invaded become polarized into a spinning vortex, because the spinning part of the center of the vortex is polarized like a little bar magnet spinning just as fast as hell. And when it hit the glass of the unrestricted space, it shattered it into these fields. Now that one right there is, I believe, a reverse spinning particle. Now, I take exception to all of what they're saying about right-handed rules and sterile neutrinos and all that. It gets very complicated, so I don't want to drag it through the mud here too deep. But you can see what you see. That one's doing a different thing than all the rest of them. They all came from the same source through that accelerator, Crusher Venturi. They came out, and those particles, which we saw going and forming white little corpuscles, are now these white little corpuscles in these trails coming out. So fast that they cannot interact with the particles that are around them. The particles cannot move quick enough to react to that spinning boson until it slows down to just a taste, and then all of a sudden fluffs up like popcorn. And that's what's happening there. Okay, now, seeing what you just saw, and seeing all those fields fluff up when those boson particles, the real screamer particle, finally slowed down enough that they could react. That's when we saw them all fluff up in the fields around them. Now, we did see that little white particle, and that is that little white particle right there. That one right there. Now, why was it white? First of all, I say it was because it was spinning backwards. And because it's spinning backwards, it is gathering the field into itself instead of splattering it out into other electrons. It's grabbing it into itself. Now, it appears to be discharging into a standard field. So are they annihilating each other? I don't know. That's the only picture I have of this particular interaction. But it's extremely clear. There's nobody can say that as not as extremely clear interaction of this particle, which you can see, if you look at it carefully, you can see its structure. There's a structure there. And that structure is smashing into this structure. And whatever that is, it's creating a mini field. So, we started with light, which is supposed to be the absolute smallest particles that exist. And now we have this. So I say there's some things to be looked at here. And the Venturi is the device that can deal with electrons. Now what they do in CERN is they take a gigantic ring, I mean miles and miles around, and they spin particles, big heavy chunks, protons. I'm using electrons. They spin them around head on. And then they get all of these showers coming off them. And they get the exact same showers because they're breaking off the same little bits. Only they're bigger chunks because they started out with 8,000 or 4,000 times the size of what I have here. So they're getting lumps that might be 100 times bigger than the one I'm showing, but it's still the same lump. But it's just more particles in that lump. Because everything's made out of the same two particles. An upspin electron and a downspin proton. Positron. Now, you call them either way, upspin, downspin. One of them's going up, one of them's going down. So I don't care which one you call them. But they're opposite spins. And that's what creates the bar magnet type of attraction into these dipole spinning particles, which we call light. And this is those spinning particles. As they come out, remember I say, they come out so fast they can't interact. Then all of a sudden, poof, they fluff up, and then poof, they go away. You get a couple of patterns like this, and I believe that is a real close-up shot of the interaction just before it creates the Higgs fields. That's all I can take away from this at this point. And the red laser does the same thing. That's coming out of the accelerator, and then they come out. Red smashes a little earlier than the green. The green would have gone way out that way. But you get the two particles. One of them's a little higher, and one they squat down a little bit. It looks to me. I'm just looking at what I see. I don't have the equipment or probably the expertise to understand 100% what I'm seeing. I go by what I see, and then I try to understand what I see. And nobody else is doing that. It's just some silly thing. We can't explain it, so we don't want to talk about it. Well, I can't explain it either, but I do want to talk about it. And what I'm seeing here is two dipoles back to back. A dipole is a positive and a negative together. And to me, Black and white is positive and negative. Now, you got a dipole this way, you got a dipole that way, you got a dipole this way, you got a dipole that way. Now, how is this just red only this size, and then green gets bigger, and then blue gets bigger than that? I think that is the case. I believe that's the case. I don't believe all light is the same particle, just one faster frequency than the other. I think they are bigger particles, because red will not displace electrons, and it will not push a Crookes radiometer. It won't make it spin. Green and blue will. And full spectrum light, which has all of the different colors, will. But this will not. Why won't it? I don't care how high you turn up the power of the red, it will not move that, because there's not enough power, there's not enough electrons smashing, there's not enough substance. So I have to conclude it's a smaller particle. Blue will always displace electrons. Red will never displace electrons. That's my tip-off. Okay, this is light, and I say that is the particle of light, and it is a particle. We've seen it as glowing as it concussed in the other shots. This is accelerated because you can see the expansion here and the compression up here. It's slowing down. This is the boson phase, and then it becomes the Higgs phase as soon as it slows a little more. But what I am seeing here is right-hand spin. Now you'd say, oh no, it's drifting to the left. Well, it's drifting to the left because it spins to the right. Now they call these sterile neutrinos if they drift to the right. No, I call those normal light if this drifts to the right. That's normal light. A sterile neutrino, whatever they want to call it, a left spin is the gathering spin that I showed before that created that crazy looking little semi-spinner. So I'm saying that a right-hand spin, and that is, everything spins to the right, and that is the fluid movement of particles in any media. They spin to the right. If they don't spin to the right, they are counter spinning. That is a reverse spin to the left. It's not the correct spin. Some of this stuff I can't understand what they are actually trying to say, whether they missed everything or I'm missing everything. These are the kind of charts and diagrams and things they've come up with: the weak force, the strong force, electromagnetism, gravity. There's nothing more than magnetism. All of this stuff is nothing more than magnetism. Now, but they've spread it out into, this is bigger pieces, these are smaller pieces, this is when it's moving through the boson phase, this is when it's doing something else. You know, they sort of picked up on the little bits and pieces, but nobody's putting it together. You cannot have the interactions that exist with a big gigantic proton, a big gigantic neutron, and a tiny little electron. It's impossible. There's resonance frequency at 1836 particles like this, something similar to a chunk of particles, and when they all settle down at 1836, they stay together. 1837, it will hold on. Yeah, you got one extra there, which is keeping this as a negative. It's not neutral, it's negative. Now, at 1836, it's stable. You go to 1840, and there's chunks are going to fall off. They're going to stick out like that, or they're going to be swept away, or that's radioactivity. It's just as simple as that. Half of these would be negative, and the other half are positive. Bloop, they come together. That makes the core of the nucleus with an additional couple of electrons in there, which they call neutrons, which are additional electrons, and they create a negative core, and then you get your orbitals. And the experiments we've shown, Rod did a fabulous work, Rod Warren, on the light experiments, and you know, I analyzed every bit of them for years, and I'm 100% sure he's captured light, spinning light, he's captured the particles, acceleration, the boson phase, the Higgs phase, and possibly antiparticles and matter just fusing together. I don't know what he's captured, but I'm telling you, everything I can see makes sense to me that the particles that are flowing through that accelerator are increasing in speed, their own certain regions that are being invaded, they're turned into plasma. And I think if we could make those plasma head on, and right in the center we could create fusion. I can't see why not. And that's all you use is a Venturi, no extra additional power. I'm going to draw a little diagram, show you what I'm thinking of, because we got to do something for this, and this might work. You saw how the laser came through the Venturi and sprayed all that white stuff out. Well, if you had two of them coming head to head, using helium instead of light, so in other words, these are heavy protons at this point. This would be inside of a vacuum chamber. All right? You have your two Venturis here, one here. And you can tune these by the size of that circle and the size of this. These are metal drums. And the distance apart, you can tune what comes through here. And Rod said, on occasion when he was working with it, he could actually hear the light sizzle when it went between these Venturis. Sizzle, light itself, making sound. Now, you would need this in glass, and you would want to flood it with electrons from the sun, because that's what's coming from the sun is electrons. You're flooding it to Earth with electrons. And Earth is, the reason the electrons come to Earth and light comes to Earth at the speed it does is because Earth is the attractor. Earth is a positive, attractive source on every single electron there is, and they all have 1 electron volt. And I believe it may have increased since Milligan tested it, because I think the Earth is more attractive now than it was when Milligan did his oil drop experiment. And what he did was he tested how much energy, electricity it took, electrons, to push up an electron to keep it from coming to the Earth. So what is that? That's magnetism. The electron, negative, wants to get to the Earth, positive. The Earth will suck every single electron you put down to it. You put a wire down next to the Earth, and it goes right into the Earth. Everybody understands this. Lightning comes to the Earth, everything grounded to Earth. The Earth says, give me all the electrons you got. That's why light comes to Earth at a certain speed. Every electron in each chunk of stuff has 1 electron volt. If you got a big gigantic chunk with a ton of electrons, it slams hard onto the Earth. It's heavy. If you have hydrogen, it doesn't even have enough electrons to come to Earth. It goes up in the air. That's why it drifts up in the air. Same thing with helium. Helium doesn't go up quite as fast. Hydrogen goes up faster because it has less electrons. It's just so simple. It's just bizarre. And the only 2 particles there are is a positron and a negatron, which is an electron. So the positron and the negatron lock together like 2 little back-to-back bar magnets and create photons. And then the bigger chunks turn into different colored photons. You get into the blue, and then when you get up past the blue, we can't see them anymore. But they are there, and they're chunks. Now you get into gamma rays, X-rays, ultraviolet, all the things that can damage you because they are chunkier chunks. All right? And they might be spinning faster in angular momentum as well. I'm sure that's probably the case. But they are chunkier chunks. They're just bigger chunks. And then when you get into nuclear explosions, that thing, when it goes off, it's sending out hand grenades. They are, instead of being one of these little things, which is light, they're like this. One of these, smash it into your face. Whole different story when you get into the nuclear, and as soon as it goes off, boom, everybody gets slammed and smashed and poked holes through with these big chunks. And then they cause all kind of damage, and that's what people die from. And then, of course, there's chunks like this laying around here and there afterwards because they can't get back together. And all of a sudden they go, bloop, and they pop back together, and a whole batch of energy gets radiated out. That's what it's all about. That's what nuclear reactions are. All right, so enough for the nuclear reactions. If we could do this, You don't even have to get up to the speed of light like they're doing at CERN, because they're going around this way and around that way and boom, head on. And they're almost both at the speed of light, and they're getting these. I don't think you'd have to do that with these Venturis. Venturi seems to crush it extremely well. The light, now I don't know, the light it owns regions just like the positive particles of the nucleus, because the light I'm taking as a negative, the positive particles of the nucleus of helium should also own regions. There should be no difference in the regions that they want to possess, which is to grab a hold of the electrons. The electrons want to grab a hold of the positives. So the regions of the particles should also be extremely large. When they have to go through that Venturi, I don't care what you do, you're going to crush them. And when they get crushed, they turn into plasma. We saw it, no question whatsoever. If you could do it with helium, what happens with helium? Well, it's actually heavy hydrogens, and it turns. Yeah, that's right. These should be hydrogens. All right, here we go. See that? How easy it is to fix things. Hydrogen's coming out of here, but it's heavy hydrogen. It's the deuterium and tritium, 2 and 3 extra. Well, there's extra particles. Let's put it that way. When they slam together the hydrogens, they're heavy. They create helium. So you're going to end up with helium in here, and as a byproduct, you end up with a whole batch of extra electrons. I say there'll be 1,836 extra electrons, which you could suck through that electrode on every single particle interaction. So that's a lot of power. If you could do this, we could get fusion. And there's no extra power required for here. All you got to do is shoot your little hydrogens out, and then nature takes its course. And you need something in there to suck out the electrons. There's some electrode in there. Send those off to do whatever you do with your power, and life goes on.